Hello everyone. So today we will see a few more RC circuits with uh, current inputs. Okay. So in this question you have to draw the waveform of V0t and VIT for this input. Okay. So in the previous video I have solved many circuits with different inputs. So now in this video you have to solve the circuit for this input, and there is one more question. Okay. So first we will see this one. So first we have to draw the V0t. Now you know how would V0t look like. So it would basically be 1 by C IT into TT. See, I have already explained what is a ideal current source and how a capacitor behave when it is connected across the current source only. See, all of them have been explained in the previous video. Okay, so the current source would simply charge the capacitor in this direction. Okay, so first we would see from 0 to t by 2. So it will, so the current is flowing current is flowing in this direction, I naught current. Okay, so it would be I naught t by 2c at t by 2. So for 0 to t by 2 it would charge from 0 to it by 2c. Okay, and also we can write it t equals to 2rc, so it would be I naught t, I naught t, so 2rc, so it would be I naught r, so it would charge from 0 to I naught r. Now what happens, at from t by 2 to t, the current direction is changed, the magnitude is same but the direction is changed. So first the capacitor was charging in this direction, now it will charge in this direction. Okay, so first it was charging like this, now it will discharge. Basically it is charging but in this direction it is charging, so uh, so we can say it is discharging only. Okay, so see, we can write the equation as well. V naught t equals to I naught t by 2c. Now for t by 2 to t, the current is minus I naught, okay, into dt by c. So how, what would be the voltage at time t? So it would be, I should put t here, minus from t by 2 to t. So at time t we are checking, so what it would look like, so it would be 0. Okay, so first it is charging and then 0, then again charge, then again 0. So this is how the V naught t would look like. So uh, so this is the process, and what you can simply see, we are simply integrating the waveform, and we are dividing the magnitude by 1 by c. That's what we are doing. Okay, simply integrate the input waveform and divide the magnitude by c. Okay, so here I will draw V naught t. This is I naught t by 2c or I naught r. Okay, now talking about VR, only VR. Okay, not VIT, only VR, VRT. Okay, only VRT. So it is basically the voltage across the resistor only. So what would be the voltage across the resistor? Voltage across the resistor VRT is equals to I IRT into R. So what is IRT? IRT is IT only. So whatever the current is flowing through the resistor, if we simply multiply the current with resistance R, we will get the voltage across the resistor. So the VRT would look like this only, and the magnitude will be I naught R and minus I naught R. Okay, so it's very simple. Now what you need to do, you need to draw VIT. So what is VIT? VIT is basically V naught T plus VRT. So basically you need to add both the waveforms. So you simply need to add it. Okay, so where it would start from? To start from, this is 0, this is I naught by R, so it would start from I naught by R and will reach up to I naught by R plus I naught R into I naught R. So it would reach till 2 I naught R, from I naught R to 2 I naught R. Okay, now what happens? Now the current is flowing in this direction. You can see from this, or you simply need to add. Okay, so at time equals to t by 2, here we are having minus I naught by R, or here plus I naught by R, so it would come down to 0. And at plus and at t, what would be the result? At t it would be minus I naught R plus 0. So we are doing nothing, we are just adding the waveform. That's it. So it's minus I naught by R, and the same process will go on. Now at t, what we are having plus I naught R. So again plus I naught R, then again this, then again. So like this it would go on. Okay, so it's t by 2 and it is t. So this is the waveforms. Okay, so moving on to this one. So in this question also it's given t equals to 2RC, and you have to draw the waveform of V naught t and VIT. V naught t will be very easy. First I will draw the waveform of V naught t for all the inputs, and then we will move to capacitor voltage, and then we will add both the voltage. Okay, so first talking about V naught t, what would be V naught t? V naught t will simply be IT into R. So simply talking about the voltage across the resistance, we will simply need to multiply the waveform with R. That's it. Then we can simply get the waveform of V naught t. So I have already drawn the waveform. I simply need to multiply it with R. That's it. Okay. And talking about the capacitor voltage, for capacitor voltage, what we need to do? We simply need to integrate it. So this is step input. What would we get by integrating a step input? We will get ramp input. I have already explained it. See, VC T 1 by C integrator IT into DT. So it would be IT by C. So simply it would increase. So I'm talking about the voltage across the capacitor, not VIT. Okay, only voltage across the capacitor. So it is increasing. Now talking about this one, I have already explained it in the previous videos. Now you simply need to integrate it and divide the magnitude by C. Okay, now we will integrate it. See, first what happens, we are applying T naught I naught amount of current to the capacitor, so it's charging till I naught T by 2C. Okay, then there is no current applied, so it is open circuited here. It is open circuited here, so there won't be any charging or discharging. So capacitor will store its charge, so there will be no change. Okay, then again increase. See, it will carry on the previous amount of voltage that it has. See, okay, and then again constant, then again increasing. I have explained it already in the previous videos. Like first I naught T by 2C here, then there is no charge, then there will nothing happen. Here nothing will happen. Then again I naught T by 2C plus I naught amount of current. So again it will increase. Or simply you can integrate it. We studied in signal system simple integration. Okay. So it's T by 2, T 3T by 2. Okay. And now for this input, I don't need to explain because I have explained it here only. This waveform, so it is the same, nothing else. So now we simply need to integrate it, so it would look like this. Okay, I forgot to write the magnitude here, so it would be I naught T by 2C or I naught R, and here it would be 2 I naught R. Okay, now we have to draw VIT. So for the first input we need to add it, so I don't think I need to draw the waveform here. You can simply see the waveform would start from I naught R and will keep on increasing. Okay, and for this input, you think how would the waveform look like? It would be the same only, because what you did here, you simply add these two only, and here you need to add these two only. Okay, so it will be the same like the previous one, like this one. So now only this waveform, for this input only I need to draw waveform for this one, for the second input. Okay, for the second input, see you can draw the you can add the waveform by your own, but if we directly have to draw the waveform of VIT, then what will we do? Okay, so first I have to remove these. Okay, not working. Right. See, so what will we do? See, first we have applied I naught current, amount of current for 0 to t by 2 time. So here the voltage will be I naught R, and and across the capacitor the voltage is constantly increasing. So the waveform will start from I naught R, and because of the voltage across the capacitor, it will increase till T by 2. So it will increase from I naught R to I naught T by 2C, and because of the condition given, this is equals to I naught into R, so it would increase to 2 I naught R. Okay, so it is 2 I naught by R. Now what we have done, we have applied zero current, meaning we have open circuited this one. Okay, so there would be no voltage across the capacitor. When there is no current applied, there would be no voltage across the capacitor, no voltage across the resistor. Okay, and the capacitor would store its previous value, that was equals to I naught R or I naught T by 2C. So it will only store I naught T by 2C. So what would be the value of VIT? It would be plus I naught R only. Okay, because there is no voltage here. So the waveform would come down to I naught R and will remain constant. So it is T by 2 till T. Okay. Now what is the amount of voltage capacitor is having? It's plus I naught by R, I naught into R, and now we have again applied I naught current. Okay, so this is the previous charge. Okay, and now again we have applied the current, so VIT would start from 2 I naught R and will increase till 3T by 2. So how much charge will the capacitor store? So the capacitor will store 2 I naught into R charge. Okay, so see, first it is having I naught R charge, and the voltage across the resistor will be constant I naught R. Okay, so I naught R charge is already there, but because of the current applied, it will again store I naught R charge. So it will end up till 2 I naught R, and 2 I naught R plus I naught R, 3 I naught R, 3 I naught by R. So we will be having 3 I naught R charge at 3T by 2. Okay, so basically at T it will start from 2 I naught by R and will reach till 3 I naught by R. Now again capacitor is storing 2 I naught R charge, and again we have open circuited this one. So what would be the amount of voltage across Vi? So it would be I naught R. So it will again come down, again remain constant, then again it increases to 4 I naught R. Okay, so this is at 30 by 2 and this is at 2T. So this was the explanation. Otherwise you could simply add those two waveform. So you would simply get a VIT. Okay, see what would you do? You would simply add I naught. It would start from I naught R and would end up at 2 I naught by 2 I naught into R. Then again constant at then again it will come down to I naught R. Then again increase and would end up at 2 I naught R plus I naught R, 3 I naught R. Then it would again come down to 2 I naught R. Then again increase and would end up at 4 I naught by R, 4 I naught into R. Okay, so this is how the waveform would look like. So this was the expression of VIT. See again, I messed up the English here, I guess. I'm not that fluent in English, but I have already mentioned that people want me to make the videos in English, so I'm trying now, but I stammer a lot when I talk in English because I'm not habitual of it. So I'm trying, but you may put your reviews in the comment section. Okay. So I guess I have dealt with almost every possible RC circuit in my channel. First I dealt with the voltage input. Now I am dealing with current input. So if I find more examples, then I will come up with those. Otherwise you can think by your own. So I guess this is enough for any interview. They won't ask any other RC circuits. This is what I think. Okay, so there is videos on capacitive circuits and RC circuits, so you may refer to those as well. Okay, thank you.